So today we are going to start our fourth webinars, our last webinars for Mangrove Education Program. So let me share my screen first. And today we are very happy and glad to have Prof. Dr. Ahmad Atif, Muhammad Fauzi, and also together with Dr. Noriza and also Dr. Jaisuman for our topic today, using robots in the conservation of mangroves. First of all, let me introduce myself. My name is Wano Zanika, and I'm a program education officer of Malaysian Nature Society. And today I have my colleague, Miss Sashikala, and also Wan Fatin and Vincent from University Putra, Malaysia. Before we go any further, just a little housekeeping. To all students who would like to ask questions, please type in your questions in the chat box. We will read your questions during the Q&A session. And also, if you have any comments, you can communicate in the chat box. Please mute yourself during the presentations, during the talk. And yes, if you have any comments, you can use the chat box. Now, I would like to just to introduce about our program. So this webinars is a collaboration between Malaysian Nature Society and University Putra, Malaysia. This webinars is one of the project initiatives in collaboration with TEEN under the Asia at Connect program, sponsored by the European Commission, entitled Sustainable Aquatic Resource Management in Mangrove Ecosystem via Internet of Things application, or MEITA. So the objectives of these webinars aim to increase the awareness and knowledge of the mangrove ecosystem, the importance of its conservation, and introduction to more efficient monitoring methods in mangrove forest conservation efforts through the use of technology. So for today, today is our last webinar session, and also I would like to inform regarding the quiz and essay competition. So today we have Dr. Evelyn will announce our quiz competition after the end of the Q&A session. So we are running two competitions for this in regards to these webinars, essay and also quiz competitions. Later on, we will share the link to all the students, and you are welcome. You are all invited to join these competitions. And for the agenda today, so after this, we have Prof. Atif and Dr. Jaisuman and also Dr. Noriza to give a talk on using robots in the conservation of mangroves. And at 3:30 p.m., we will have a Q&A sessions. And we have an announcement of the quiz contest at 4 p.m. afterwards. And before we end the session, we will have a group photo. Now it's my pleasure to introduce our guest speakers for today, Prof. IR TS Ahmad Atif Muhammad Fauzi. Prof. Atif is a professor in the School of Electrical Engineering, Faculty of Engineering, University Technology, Malaysia. Prof. Atif is the director of the Center for AI, Artificial Intelligence and Robotic, Cairo, University Technology, Malaysia. He engaged in the research fields of actuators, pneumatics, soft mechanism hydraulics, and motorized actuators, and concentrate his work in the field of robotics, bio-inspired robotics, and biomedical application. Prof. Atif is also a professor, professional engineer, a chartered engineer, and president for Persatuan Saintis Muslim Malaysia, committee members of the Malaysia IEEE Robotics and Automation Society, and a member of 2 Academy Science Malaysia Special Interest Group of Biodiversity and Robotics. And the second speaker for today, I would like to introduce TS Dr. Jaisuman bin Puspanathan. Dr. Jaisuman, a senior lecturer at the School of Biomedical Engineering and Health Science Faculty of Engineering. He is also the research fellow for Sports Innovation and Technology Center, University Technology Malaysia. His research activities are in the field of biomedical engineering and drone technology. As part of the community service, Dr. Jaisuman frequently appears in webinars, media, and organizing drone-related activities for public. He's currently the president of Southern Drone Club, which focuses on drone community and activities. And our last speaker today, I would like to introduce Associate Prof. GS Dr. Norizah Kamaruddin. Dr. Norizah is an Associate Professor at the Forestry Science and Biodiversity Department, Faculty of Forestry and Environment, University Putra Malaysia. She received her PhD from UPM after receiving her first class honor during her bachelor degree. She continues her postdoctorate study at the University of Montana and Oregon State University, USA. Her research interests cover a range of areas in forest operation, mangrove forest management, and geospatial technology application. She is also active in the institution of Geospatial and Remote Sensing Malaysia. Now, without further ado, I would like to call upon Prof. Atif to present his topic. Hello, Prof. Whenever you are ready, the floor is yours.
Hello, okay. Sorry, I cannot unmute myself.
Oh, yes.
Okay.
Earlier I made you as a co-host.
Okay, thank you very much for the introduction. Everyone, can you hear me?
Yes.
All right, okay. So, Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Ahmad Atif Muhammad Fauzi, and topic of our talk today will be the using robots in the conservation of mangroves. And the first topic that I would like to share is on the introduction of robotics technology. And later on, Dr. Jaisuman will be detailing the drones, aerial robots, and after that, Dr. Norizah will also highlight some of the functions on how we can use robots for the conservation of mangroves. Okay. Before we start, just I'd like to highlight what is CAIRO. CAIRO is the Center for Artificial Intelligence and Robotics, and we have 8 members at the moment with 2 offices. One is in Kuala Lumpur, CAIRO Kuala Lumpur, and the other one is in CAIRO JB. And our center was founded in 1997. So for this year, it is now 20+ years of establishment of the center, and the center is focusing in the area of robotics, AI, and also in control. This is our research area in our lab. We call ourselves as A2 Lab. So A2 Lab is one of the labs under CAIRO, And under the lab management, we are working in these three main areas. Bio-inspired robotics, something that moves very softly, like this snake here. And we also have developed a different kind of bio mimicking robots. Secondly, we have rehabilitation robotics or in biomedical research, where we use most of the soft components in this research. And thirdly, we are working in the area of field robotics, where here drones, mobile robots, underwater robots are considered as hard robotics. Okay, we use hard materials like metals, aluminum, and so on. And in the blue box here is a little bit more detail of fundamental work that we do in our lab. Okay, so next I would like to invite everyone, if you can join me for a short, quick survey on our topic. So you can go to menti.com, okay, or you can use your QR code, camera devices or whatever, iPad that you have, and join for this QR code with code of 31420251. Okay, if you cannot enter by using your QR code, you can just type www.menti.com and then you can just key in this 8 number of 31420251. Okay, let me also do this together. Okay, right. So if you can just enter this, it won't take long. Once you scan, so then you can just enter yourself in the Menti. Okay, anyone have finished joining? Is there any problem? Okay, so the first question that I would like you to answer is, okay, you are currently in standard 1 to 3, standard 4 to 6, you are in form 1 to 3, form 1 to form 4 to 5. Are you a teacher or a lecturer, or are you a university student, either postgraduate or undergraduate or postgraduate, and others? If you are engineers, you are in the category other than these 5 areas. So you can just click and submit. Anybody have problems to enter this? It is not updating. Maybe there are some error. Right? Okay. Okay, now we can see that most of us are coming from Form 1 to Form 5. We have 13 from 1 from Form 1 to Form 3, and then another 12 from Form 4 to Form 5. And we also have our friends from universities and graduate students, PG students that is joining us today. So all together, we have 51 members at the moment. So for those who have already joined in, so please, just we want to know you are from which category of attendees. Right? Okay, thank you very much. Okay, next we want to go for the second question. This is just 2 questions that I have you before we start. What do you think of when you hear the word robotics? Okay, right. So you have 8 category or 8 words that you can use. Okay, I have the first one here, electronic. Any other, or if you know any of available robots that you want to share, you can also just type them in the box that you have there. Okay, we have the first one, electronic. Okay, let me share with you also for those who everyone in the meeting. Right. I can see here electronic. Maybe I have to refresh. Only one. Okay, so now we can see different kind of words. Programmable machines, convenient, modern, AI, creative, robot itself, futuristic, machines, high technology, machinery, and so on. Okay, so we see here there are some functions of robots. For example, it can be a machine that can move and it can save time here. And I think the characteristic of the robot itself. So a robot is a programmable machine. It is part of the future technology. If you following the IR4, the Malaysian direction for the high-tech nation, so robotic is one of them, right? So we would like to hear if you have any other keywords related to robotics. So later on we can share in the question and answer session. Okay, we also have robotic arm here, one of the examples of types of robots. Okay, thank you very much for all 22 participants who have filled in the keywords. I believe there are a few more, but due to the delay, so the words are not being displayed clearly. All right. Okay, let's move to the presentation back. So thank you very much for the participation. So I would like to start with sharing the available types of robots. Okay, according to the International Federation of Robotics, right? So there are two main types of robots. The first one is industrial robots, and the other one is service robot. So they have this ISO definition, whereby the industrial robots are considered as robots which is automatically controlled. It is reprogrammable with multi-purpose manipulator in 3 or more axes of motions. Okay, so we see here most of the available robots in industries, they have more than 3. Normally we have 6 degrees of freedoms. And these machines or these robots are being used mainly in industrial automation application. For example, we want to fabricate cars, making different kind of fixed automobiles, aeroplane, and so on. And in the meantime, we have another type of robots which are called as service robot. And a service robot is a robot that performs useful tasks for human or equipment, excluding industrial automation applications. So something which is not in the industrial automation, so then we justify this as service robot. And according to IFR, okay, so we have 2 types of service robots. One is a professional service robot, and the other one is we call as domestic service robot, right? So this is an example of where these 2 types of robots are being used. So maybe for those of you who are in your secondary schools, okay, maybe you don't have experience going for any factory line. So this is actually how most of our cars are being fabricated nowadays. So robots are developing and fixing the components of cars. And in the meantime, for service robots, we have this, for example, a vacuum cleaner robot that can go around and clean shopping malls. So, okay, some of the robots like this one, we have Pepper robot, for example, that can greet you when you arrive at hotels and so on. Okay, I have a video to show some examples of available robots. Okay, so this is examples of a robot from Boston Dynamics, which is currently having a little advancement compared to the normal industrial robot. So one of the advancement that we have here is it is having a mobile base structure which is moving by itself. So the structure of the robot itself is not grounded to one position. So the robot itself can move from one point to another. Okay, so if I can drag here, so you can see how the robot itself is having a gripper to grip something using a suction mechanism. And later on, we can see how it can be used to do pick and place, normally in industrial functions, but it is not meant for car fabrication. So it is meant for pick and place functions, okay, like for example, carrying boxes and so on. And in the meantime, we have another type of robots, which is also from Boston Dynamics. This is a very recent robot that was a recent video that was published by Boston Dynamics. So if you can see here, the name of this robot is Atlas, and they have a very advanced function. The robot now can jump, can do backflip, can stabilize itself. So if you can see how it navigates and locomote in different area with different steepness, even I think for us, it's quite difficult for us to do backflip, right? So you can see here now how this is example of a Parker sports, okay? So, and at the point here, you see here how the robot itself can do backflip. I'm not sure if some of you can do the same like this robot do. So that is something remarkable, okay? Very highly programmed with different kind of sensors to achieve those movement and function. Okay, let's move to this slide where we want to discuss on what makes a robot robots. Okay, so if you see here, just now we are talking about industrial robots where they have like a gripper, like a manipulator, or we call as an effector to do picking and placing. So they have to identify the position of the object that the robot should be picking up items. And normally for human, we have our eyes, we have our mouth, we have our ears, we have our hands like skin to do detections. But for robots, we have to also use different kind of sensors. But the sensors itself is coming from technology of camera. For example, we have also push button, we have ultrasonic sensors, laser sensors, and so on. And this will be the eyes, the ears, and also the skin of a robot. Okay, the camera itself is the eyes of a robot to detect, to identify the movement, the motion, and so on. In the meantime, when we want to have the movement, the functions of the robot, for example, we saw how Atlas jumps, right, from one block to another. So the actuator is the devices that we call as the mover, okay, or easily we call as actuator to actuate movement. So we have motorized base, we have hydraulic base, we have also simple actuators that we categorize as buzzer to produce sound. For example, now I am talking, so the voice that I am producing is considered as output, okay? So, and we also have LEDs. So for example, lights, small sizes of light we call as LED, that emitting diodes. And this, both of sensors, or we call as input, actuators or motor we call as output, are controlled by the brain, okay? So the brain of a robot are called as microcontroller. Okay, microcontroller is the brain of the robot. So how does the microcontroller looks like? So the microcontroller looks like this board, or maybe I have one live here that I can show you. So this is a type of microcontroller. Okay, so this microcontroller we have to program, and we have to connect the input, the sensors, and also we connect also the output, the motor. For example, we're going to talk about drone later on. How does a drone fly? Okay, Dr. J will share with us the movement of the drone to move forward, backward, up and down. So the sensors are very important to decide. So normally we have manual way of controlling, for example, using a joystick. So you push forward, the drone will move forward. Okay, so the signal is coming from the joystick. The joystick is having the button or maybe some toggling input, and the output will be the motor. The motor will be spinning from clockwise, anti-clockwise, and so on. But then the brain will be deciding what to happen. Okay, so this is basically the block diagram of a robot in a very simple way. You have an input of sensor, you have the output of actuator, and then the brain itself. Okay, it's like our brain here. So how we decide to interpret whether we are having pain. For example, if we have like a spina here, and you knock your head, then you're going to feel pain, right? So the translation of those pain are being decided by the brain. So our brain is the microcontroller, assuming in the robot's function. Okay, so today we are going to discuss about 3 different kind of available robots. So ground robots. Later on, we're going to look at the underwater robots, and we're going to have the final one, the aerial robots, which is going to be explained in more detail by our 2 speakers, Dr. J. Suman and also Dr. Noriza. Okay, so allow me to share with you some of our work that we have in the lab, in A2 Lab. So the first ground robots, we developed Inspecto. So this is the name of our robot, which is used for duct inspection and cleaning robot. And later on, we can see how this function of robots can also be used in the conservation activity. So we can change some of the function, and later on we can use in the conservation. So most of you, if you are in your office, maybe you have your room to be air conditioned. So either using this split system, or you have the normal AC using this AHU. Okay. So, and this AHU is having the duct area which need to be maintained. So if you are coming to the lab and you are feeling sick, you have headache, sore throat, or respiration problems, so maybe this is due to the unmaintained, unclean ducting. Okay, so the normal way of looking on the maintenance is they have to inspect by themselves, wearing the mask, for example, and they have to do cleaning manually. So it's quite painful, quite troublesome. And this is how we design a robot that can do the function. Okay, so it's like playing a game. You have your phone, and then you have the joystick function here, and then the robot will be moving left and right, up and down. So we can control the spindle, the rotation of the motor, to do cleaning for this function. So this is an example of how we control. If you look here, the input will be coming from the pad, the tab, sorry, and then the output will be the motor movement. Okay, the motor movement, front movement, back movement, the rotation of the cleaner. So all of these are actuated, and inside here we have the microcontroller to decide the function. And we also have different kind of sensors. This is another example of how we use a laser-based sensor to do mapping. Okay, so this is an example of a type of laser that can be used to map ducts area which is not available for certain building. Okay, so what we want to highlight here is the function of the robots that can be used in small area, small spaces. If we have like 2 by 2 feet of duct area, or maybe 3 by 4 feet, so then we can utilize this robot to do the cleaning of the duct in your building, or normally in our houses we don't have this kind of air duct. It is normally in hospitals like this one. We went to hospital to help and do assistance in checking the quality of duct at one of the hospital in Johor Bahru. So there are some other visits that we went to show how this system should be working. So this is a demonstration that we went in Putrajaya with the previous version of the robot. This is still the 3rd version. And I think this one is the recent visit that we went to another hospital. I will tell you later why hospitals. And this is an example of the movement of the robots. Okay, if you can see here, the operator is controlling the robot by the phone, and we can see the images of the real images inside the duct. And this is example of the images of front camera. Okay, this is how the robot is moving forward, and this is example of how the back camera movement. Okay, so why we have this back camera? Because the robot motion will be moving backward later on. So when you want to go back, you don't have to twist, you don't have to turn around, you don't have to make U-turn, you can just go back by reversing. Okay, so this is example of how we've utilized the function of cameras. Okay, why we go for healthcare or maybe hospitals? Because the inspection for hospitals are quite important. Okay, so this is why we are trying to go. So examples of how we can do these functions in conservation of mangrove is one thing that we are still discussing with the experts. One of them is trying to have a sensor or camera to detect the height of the trees. Okay, we can have a camera, and then we can use the robots to crawl around the mangrove area. Then we can detect, get the height of the trees using a sensor or using a camera. Okay, so now I want to share with you the second work that we have in the lab, which is the underwater robots. And we call the underwater robots that we have developed as ROV Pleco. So Pleco is the name of fish. I'm not sure for those who have aquarium in your house, kenal tak ikan bandaraya? Okay, ikan bandaraya. So ikan bandaraya is a type of fish that normally suck the dirt. Okay, the full name of ikan bandaraya is the scientific name, Plecotemus something. Okay, I forgot the full name. Okay, you can go and Google the name of Pleco. So here we put the name of Pleco coming from ikan bandaraya name, right? So the right figure here is the third version. This is the latest version of the ROV that we have developed. And we would like to see also how it can be used in conservation. Currently, we use this for tank cleaning. So for example, if you have your water coming up from the ground tank or maybe elevated tank, most of our tanks are cleaned manually, or they call divers to do cleaning. So here, it is quite troublesome. You sometimes one whole day you don't have any water connection because of the water disruption to do maintenance. And here, how we want to introduce robotic solution to do the cleaning process. On the other hand, we also have aquaculture tank. Okay, so aquaculture tank is where most of our shrimp, udang yang kita makan kan. So if you see here, the way that they maintain is quite unhygienic. So how this process can be improved later by also using robots. Okay, so this is how we propose underwater robots that can be used so that nobody will be entering the tank. Okay, so that it will be more safer. So the time of setup will be faster, and importantly, there is no water disruption. Right. So currently we have this version. Okay, if you see here, our researcher here, Brother Wenkit here, we have Brother Wong here also helping in the setups of the experiment, the cleaning process. And now the system is upgraded, if you see here. So the black color is the new version of the ROVs. And this is the old days. Okay, if you see here, this is the previous version that we have. And we do the testing in some of the available water tank in Johor Bahru. And also we conducted some different kind of experiment as well. So adik-adik, you can also think of how we can use this robot for the conservation of mangrove. Okay, for example, underwater, under the tree, if you understand from the previous 3 talks, we understood that mangroves is very rich in biodiversity. Okay, you have how crabs available, if there are some other kind of flora and fauna. So we don't have to do cleaning. I'm sure we don't need to do cleaning in the mangrove area, but then we can use the function of robots underwater to detect, or maybe use underwater camera later on to identify how many crabs available, for example. Okay, so this is example, another photos to show our actual testing in different sites. But we haven't tested in mangrove area. So this is something that you and me can collaborate, we can work together and see how it can be functions in the conservation of underwater creatures. So currently we are focusing in water tank, water pools, and also in agriculture ponds, okay, to do maintenance, cleaning. And in agriculture itself, we have more than 5,000 ponds, I think more, okay, in Malaysia, which needs maintenance. And most of the current cleaning is currently conducted by using human. So we can reduce the intensiveness of foreign labor, for example, by having robotic solution as well. So this is the journey of the robotic. You cannot develop one robot and consider it done within one day. So there are few prototypes that have been done throughout the process with different people, different researchers to make sure that it can be used later. Okay, before we go for the drone, some of you will also think how robots can be intelligent, okay? Because now you can see that robots is having its brain function, and we can integrate it with artificial intelligence. And normally this artificial intelligence functions is coming from perception. So for example, if we have our eyes, we can differentiate between a marker and a pencil, okay? But then for a robot, they cannot differentiate it directly. So what we have to do is, we have to differentiate those. For example, this is a video that shows how a camera can do detection of human, okay? And if you see from your phone, currently, most of the phones, it will be having an automatic focus function. So if you want to take a photo of your baby, for example, then it will be zooming directly to the face of your baby, so that the image will be clearer. So this is a function that we call as object tracking. And the same functions of AI we can also use to do counting also. So once you can detect, then you can count. Okay, for example, this is a sample of videos taken to count the car from left to right, and also from right to left. And even I think while we are talking, we didn't manage to count 16 cars moving left to right, and right cars 31. Okay. I think admin, please try to admit some of the students who are going to enter. Okay, I cannot admit all. All right. Okay, and by having this AI function, we can see that a different kind of images or maybe objects can be differentiated. So for example, just now in this video, we just count whatever movement of vehicles, right? But then with AI also, now we can differentiate which is car, which is truck, okay? And maybe if we have more motorcycles, we can also differentiate between these three. Okay, car, truck, and also motorcycle, or even bus. Okay, so this is how the integration of robotics and AI is coming, whereby, for example, if we have the previous robot that I show you, so by using the camera of the robot, integrate it with AI, then, for example, if we see something inside the duct, impurity, for example, like this one, then we can detect directly. So without further notice, then this robot will be notifying the operator that, hey, this is something which is not supposed to be here. Okay, you have to clean this. Okay, so this is how AI is coming together with robotics to assist human, to assist us. Okay, in biodiversity, we can use, actually this is another work that we do with a different kind of underwater robots to do detection and also identifying different kind of turtles. Okay, so we have different beautiful turtles here in Malaysia. So how to differentiate between penyu hijau, green turtles, and then ada penyu apa hornbill and so on. Okay, different kind of turtles. So this is how AI can come and assist. Okay, just that taking images of AI and also live feedback of turtles motion is quite difficult because turtles is moving very fast underwater. Okay, it is slow above the water, but underwater they are moving very fast. So even the robot couldn't catch them, not catch them, couldn't get their image properly. So that is one of the challenge. Okay, let's move to the final robots. Okay, the flying drones, right? So by using some of the sensors, we can do, this is a work that was done by some of our members. We can do images by using LiDAR, the same sensor that I have told you earlier on do mapping. We can also reconfigure type of available components using LiDAR sensors, and we can simulate the picture again. So for example, a coconut tree here, the tower here, and so on. Okay, so this is another technology that can be integrated with drones and using AI. So what Dr. Zul did was instead of counting cars, now we can count cows. Okay, car and cows sound similar, but then cows is lembu. So how we can count cows? For example, 24 cows by using drones. Okay, the same technology can be used also in different kind of for example, in agriculture, we want to differentiate between banana tree with plastic bag and without plastic bag. Okay, so we put the camera in drone, and we can use AI to differentiate and count how many trees that have been covered with blue bag here. Okay, so no fruit and with fruit. So this is how we integrate robotics with AI. And finally, this is another work that was done by Dr. Zol on asset monitoring to make sure that some of the fences are still functioning. So you can imagine if we walk and to detect whether everything is in order. So it will be faster by using drones and also having AI together. Okay, so this is an example how AI and drones will come. Okay, next, Dr. J will be continuing together with Dr. Noriza on talking of how we can use drones with mangroves, especially on the conservation of mangrove. I believe Dr. J will highlight more on the principles, fundamentals 101 on drones, and later on Dr. Noriza will highlight the specialty of using some of the sensors to detect different kind of mangroves and so on. Okay. So I believe that will be end of my session. Thank you very much for listening and for your kind attention. This is another work that we did. If some of you have watched the movie, so how we can control the robots from far. So the future technology will be having something similar. So we can control robots from different area using, for example, this 5G technology. So this is one of the work that we did together with Dr. Natra as well during our attachment in Ericsson. So with that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. So I would like to pass over to Dr. J, and please visit us cairo.utm.my. Assalamualaikum warahmatullahi wabarakatuh. So pass over to you, Dr. J.
Waalaikumsalam. Thank you very much, Professor Atif. Yep, I shall begin, and I'm going to share my slide. Guys, how are you guys? If you want to shout something at the chat box so that I know you are still with us. So are you ready for the next slide? Yeah, we are going to go for on the topics about drone. Okay. I'm just getting my slide up now, just a minute. There you go. Okay, just to double check, when we have everything online, everything has to be checked before we proceed. If you can see my screen, I'm sharing right now. If you can shout in the chat box, yes, I can see. Yeah. I'm sharing a screen right now. So guys, can you see what I'm sharing now on the screen? Oh, now I have to go to the chat box and see what's happening. Okay, let me see. Okay, now I can see. All right, everyone can see. Good. Okay, let's begin. Bismillah, Assalamualaikum, Salam Sejahtera, and a good evening, everyone. So yeah, thanks to Professor Atif for the very, I would say, quite an in-depth introduction to drones. I mean, to robots, and it is so related to drones because, you know, this is what we're going to discuss about drones now. But before we go to drones and further detail into the topic, I'm sure everyone heard about Industrial Revolution 4.0. This 4.0, this 1.0, 2, 3, and 4, right? So generally what's happening is that in the previous Industrial Revolution, everything is going to be, if I use the word machinization, semua nak jadi machine, yeah? Everything is going to be everything is using machine, and then it's all electronics, it's huge, and it's robotics, right? But then now in the fourth industrial revolution, we can see that these technologies are actually integrating and communicating, working with each other. So this is the era in 4.0. You see all this amazing technology on the screen you can see right now. They can actually communicate and integrate with each other, right? Such as what? So you see like big data, there's lots of data over there and you can access through cloud computing, then you have Internet of Things, yeah. Anyone doesn't know what is Internet? If you don't know, then I don't know why are you here today. Now you are on Internet right now, communicating each other. Anyway, okay, so additive manufacturing, that's in common, we call it as 3D printing, right? And then augmented reality, AR, I'm sure you all heard about virtual reality, right? And then we actually also have augmented reality, and going on, they're going to have augmented reality integrating with virtual reality. And how is that going to be applied to drone? Okay, this is very interesting. Yeah, and this is very interesting. So my take-home message for this single slide is that, guys, you all in the secondary school students or even professional, if you are going to develop your career, you will need to have the critical skills for this technology. So if you have the skills, the knowledge for all this technology that I'm showing on the screen right now, you will definitely do good in your future. So this is the time. It's never too late to start. Yeah, go and explore into this technology. And drone and robotics will be along the line as well. Continue from here. Now let's go into the topic. I would like to ask a simple question. What is drone? Can you type in the chat box? So Prof. Atif just now asked when it talks about robotic, what do you think, right? So I'm going to ask a similar question. What is drone? Tengok jawapan dah keluar dah. Okay, chat box. Let me see. What do you think? Flying camera. Wow. Can fly and use to capture a flying robot, a flying camera. Okay. There's one similar keyword over there, flying. So that's what I'm expecting. When we talk about drone, everyone starts to imagine something flying. And that's why some people even call it as flying robots, right? But drone, D-R-O-N-E, is actually a short form of dynamic, remotely operated navigation equipment. So it's actually quite long, right? But in short, we just call it drone. So anything that dynamically, remotely operated and navigated can be called as drone in general, all right? However, we have this imagination that drone must be something flying. So it's not wrong to say that drones are also flying robots. Yeah. Okay. Now, there are two different things that we need to differentiate between drones and UAV. Because if you type the word drone on Google or Yahoo or browser, right, you will get some of the keywords like UAV, and then many of other type drones will pop up on your search result, right? But bear in mind that to differentiate between drones and UAV, UAV stands for unmanned aerial vehicle. Unmanned. So there's a keyword over here, unmanned. That means there's no operator, it's autonomous, right? So the main difference between drones and UAVs is that drone can be controlled by operator, and it's optional to have the autonomous flight capability. Autonomous flight capability, maksudnya, it means that the drone can fly itself, it will do the work and operations all by itself, it's autonomous. Once you click the button, take off, it will do its work and fly back and land. So that's autonomous. So for drones, this capability or this feature can be optional. Because if it's not autonomous, you still can fly a drone using a radio controller, or in short we call remote, right? So you still can control a drone using a remote. But UAV, it's unmanned. Unmanned, when you say unmanned, there is there's no operator to control the flight. That means it is mandatory to have this autonomous flight capabilities. So that's the main difference between the two. Okay. So another word is that not all drones are UAV, but UAV is definitely drone. Okay, in bahasa, bukan semua drone adalah UAV. UAV semestinya drone. Okay, you got it, right? Okay. Okay, now let's continue. Now, when we talk about drone, I'm sure you are imagining something like this. Yeah. Okay. You're imagining something like this. So that's the drone unit over there. Then you have some remote control, and definitely you have some display unit to display whatever it's feeding from the camera, and all the sensors, all the informations are actually feeding back to the display, and that is why you can see there's lots of information on the screen over there. Yep. And of course, you power up the drone with battery pack. So if a car runs on petrol or gasoline, so drones runs on electricity through the battery pack. Yeah, there are some drones you can use gasoline as well. That would be a different type of design. So now let's go to the basic anatomy of drone. Anatomy. So what are the basic components that the drone must have? Yeah, let's go to the first one. That's the first one, the canopy. Yeah, this is the canopy, or we call the enclosure. That's something to protect the drone. Then we have the second one is the blade or propellers. Yeah, propellers. Of course, without the propellers, it's not going to fly even if you have the motors. Okay. So the third one is the brushless motors. Yeah. Well, what is brushless? We are not going to detail into that. There are two types of motor, brush and brushless, but they are basically motor. So their work is to spin the propeller, and that propeller will generate some force to lift up the drone. Okay, the fourth one is the landing skid. What we call as the landing skid, atau we call as kaki drone. There's a different meaning of kaki drone. Siapa sini kaki drone? Okay, so kita gang. Okay. Anyway, the landing skid. So that's important for us to land the drone properly on the land, on the flat land, so that the battery pack, maybe there are some cameras and sensors, will not hit on the floor. Now the fifth one is the GPS. That's very obvious over there. GPS in the form of antenna. Yeah. So GPS stands for Global Positioning System. So we call GPS. Although sometimes when I use GPS, I still got lost. That's why sometimes I call it guna pun susah. Okay, it's just a joke. Okay, it's just a joke. Okay, guys, nothing to do with that. Okay, nothing to do with that. Sorry lah, because now it's what? It's 3 o'clock. I'm afraid if I give lecture, everyone's going to sleep in front of your screen. Okay. Now continue from here. Number 6. That's the control board. Okay, there's actually a flight controller or some electronic boards under that canopy over there. So the 7th one is a LiPo battery. Okay, the battery. This is battery slot. So you slot in the battery. Then the 8th is the frame. If a car, we call a car definitely needs to have the chassis, right, or the body, right. The same thing goes to drone. So drone needs to have the body, and we call it as the frame. And this frame has 4 arms, because you have 4 motors over here. You have 4 arms. And then you have LED lights to indicate which one is the front section, which one is the back position, right? There you go. So LEDs. Because drones, there's no front and back. It's basically drone. So it's hard for us to differentiate which one is the front side, which one is the back side or side. And so that's why we use an LED indicator to indicate. Then we can know when we're flying line of sight. Line of sight means we fly a drone between our eyesight. So as long as we can see the drone, that is what we call is a line of sight, LOS. Yeah. So when you are flying line of sight, when you look at the drone, if it spins around, then you get confused. Am I facing forward, backward, or sideward, right? So one way to recognize the drone's position or direction is to look at the LED color. And of course, you can always look through your display screen. your mobile phone, iPad, and so on. Okay, now this is a little bit more detailed over here. This is generally what I have explained in the previous slide, except that over here, I want to add in another thing is that we have this C over here, ESC. Okay, so guys, if you are using laptop, you will find this shortcut key on your laptop. But that is not electronic speed control, okay? If you click escape, I'm afraid you will leave this group. Please don't click that button. Okay, that's another joke. Okay. Anyway, so electronic speed control, basically, this is the component to control the speed rotation of the motor. Okay, so this is an electronic device over here. So then we have the camera over here. Now, for your information, guys, drone is basically something like, if I put it in a way, something like Lego. It's flexible. You can design your own. You can do whatever you want with it. But you need to have a purpose. What is the purpose or the problem that you want to solve? So from there, then you will get the idea on how to design a suitable drones or even robots to solve a problem. Because there is no perfect drone which you can fly and solve all problems. Yeah. So always based on the problem, then you design the suitable type of drone. So my point here is that if you are going to do mangrove inspection, right? You want to fly around and have a look what's happening in this mangrove area, right? Then you need to design or find the suitable sensors or even the cameras in order for you to do the job. And that is why camera plays a very important role over here. They are basically 5 types of camera. Okay, they are basically the 5 types of camera or even more. The first one is the normal camera you use for selfie in the handphones and so on, what we call as RGB camera. Yeah, red, green, blue. Yeah, so that's where you see colorful, natural colors and so on. That's the normal type of camera. And there's another type of camera under over here. You can see thermal cameras. So this is something that you can detect heat. This camera can actually detect heat. Especially in this pandemic situation, I'm sure you are so familiar with this camera already, right? When you go to some shopping malls or even to some outlets, right? They will scan your temperature, right? Some outlets, they are using image processing to actually detect our forehead's temperature. Yeah, so that's the type of thermal camera. Then you have multispectral camera. So multispectral camera and hyperspectral camera, these are basically the cameras can actually detect some something that beyond our eyesight. Okay, something that we can't see, they can actually detect it. Right? We will go deeper into that later on. And then LiDAR, this is where this kind of camera actually can project lights, and the reflection, we will capture back the reflection, then we can try interpret the image. So these are some of the cameras, the types of cameras. That is why I said, depending on your purpose, on the problem that you want to solve, you need to select the proper tools, components, and equipments to assemble and fly. Yeah. Of course, the easiest way is you go and buy a drone and fly, right? But that is not as easy as it is. We will discuss that. Okay, now there are several types of drones. Generally can be categorized according to the size and the numbers of rotors. Okay, so this is the one usually I think people commonly recognize as helicopter, right? Who never seen a helicopter before, right? Yeah. When I was small, I always remember, I always wish to fly a helicopter, to wish to sit inside a helicopter. You know, we see all those, we watch all those movies. Yeah? When you are inside the helicopter, you can actually have an eagle eye view of what's happening from the sky, right? But then today, you don't have to sit in a helicopter. You still can fly a helicopter using drones. So these are the single rotor helicopter. The downside about this machine is that it is complicated and it is expensive and it requires high maintenance. If any crash or any accident, the cost to repair is much more higher than other types of drones. Yeah. So then this is the common type that you have been seeing in our daily life, even in the shopping malls or even in the movies. These days, drones are getting very common, right? So drones, we can categorize according to the numbers of rotors or the motors, right? The one that commonly used is quadcopter. Quad stands for four motors. Ada 4 motor, just like the car, 4 tires, 4 wheels, right? So this is the very commonly used one, quadcopter. Why? Because this setting is the best, to my knowledge, the best and the easiest and convenient to control the stability and everything. Yeah. But of course, when you have more motors, the flying behavior will be slightly different. When you have more motors, think about this. Each motor requires power, right? Requires power. Yeah. So if you have more motors, it will require more powers. What does it mean? It means it will drain your battery faster. All right. So if you have more rotors, then it will require more power. Then you will have to give in more power. What does it mean? You have to give in a bigger battery. But when you give a bigger battery, then it's going to add up the weight. You know, flying things, anything's on in the air, you want to reduce weight in order for you to fly longer, right? So when you reduce weight, then you cannot have too big battery. So these are pros and cons of it. So this is one of the things that engineers who design drones struggle to find the right spot to have the balanced setting for each of these components. That is why, still come back to the rule of thumb, is that based on the problem, what is the specific problem you want to solve, then only you decide what kind of drone or even robots to do the work. Okay, now next, this one. Now this is, it looks very different than the previous one, right? You look at this, there's lots of propellers, but then this one, there's only one propeller, or maybe even 2 or 3, right? But there's a wing over there, right? There's a wing. So this is what we call as fixed wing, sayap tetap, fixed wing, yeah? Now, fixed wing actually fly leveraging on the air condition, yeah? The wind, they fly and glide on the wind, on the air, right? So it's very lightweight. So that is why the advantage of fixed wing is that fixed wing can fly very long hours. It can even fly up to 15 hours or even more, right? It glides in the air, yeah? So the purpose of using fixed wing usually is for surveying, monitoring, or even mapping on a big scale. So if you want to fly a very long distance, you need to have, what do you call this, the enough power to fly that long, right? So one way to do that is you can use fixed wing. On the other hand, multi-rotor, this is suitable to carry heavy payloads. Payloads ni apa maknanya, pemberat, ya, payloads like such as the camera or any other objects that you want to bring, you want to lift up, right? So multi-rotor is suitable to do that job. But the downside of multi-rotor is that it cannot fly as far as fixed wing can. It cannot fly as long as fixed wing can fly. So that's the downside. On the other side, fixed wing cannot carry heavy payloads as multi-rotor can. So there's a pros and cons, right? So you are the engineer, you have to decide which one is the best for your job. Now, continue from here, the last one. Okay, then, humans are the best intelligence on Earth. Yeah, we can have all kinds of intelligence, but that would never replace our human intelligence, right? So what they did is that because of the drawbacks from fixed wing and multi-rotor, now what they do is they get this multi-rotor to get married with fixed wing, and they have kids called as hybrid VTOL. Maknanya multi-rotor kawin dengan fixed wing, jadi hybrid. Okay, jadi hybrid. So they combine the two to get the best of the types of drones. So if you can see here, there are quadcopters over here, you can notice, and there's also a fixed wing, right? So what this drone can do is that it can take off vertically, just like you watch in the movie in Avengers. Anyone haven't watched Avengers? Okay, I'm sure all of you watched before the Avengers movie, or even Captain America. There's a spaceship in the air, right? And some of the airship can actually take off vertically. But if you go to airport, you don't see these kind of aeroplanes, right? Aeroplanes needs a runway to speed up, and then it will take off gradually, right? But then fixed wing hybrid VTOL can actually take off vertically, then it will fly forward straight because of the combination of multi-rotor and fixed wing. So the advantage of this is that, imagine if you are in the mangrove, yeah? You're in the mangrove in the forest, there's no pathway, it's all what? It's all muddy, right? You are not expecting a drone to, a drone to take off on the land. You don't have a runway. So how are you going to fly a drone? You can use this kind of drone, yeah, just to take off immediately from a flat land. Okay, yeah, Professor Atif also mentioned about underwater, right? Underwater robots, yeah. So this is some gray area whether to categorize it as drones or robot, yeah. But basically, if you look at the term, ROV stands for remotely operated underwater vehicle. That sounds very close to drone, right? I said that drone, the D stands for dynamic remotely operated vehicle, yeah. And there's also types of autonomous underwater vehicle. Yeah, so this is so close. Yeah, yeah. So this is something that the privilege in our era that we can actually see these technologies can actually benefit our life. So instead of sending human down to the seabed, we can actually send the drones or robots to do the work or to assist our work. Yeah, and for those who are we call what kaki mancing. Yeah, if you like to go for fishing, yeah, the good news is that you can actually send the drones to actually detect which area has the most fish before you decide to go to that spot. Yeah, so you don't have to waste your time going to the wrong spot, waiting the whole day, and there's not even a single fish. Okay, moving on from here. Okay, now we are going to go to the working principle. I just need to confirm if you are still okay, if you are still with me. Can you type at the chat box if you are ready? Just say, I'm ready. Let me see how many of you are still ready to continue. Oh, I didn't notice we have a few questions and comments over here. We will come to this during the Q&A later, okay? Okay, great. Okay, you are ready. Okay, I'm ready too. Okay, let's go. Now, this is the basic working principle. Okay, just like Professor Atif mentioned just now, the 6 DOF, 6 degree of freedom. Yeah, doesn't matter if you don't memorize it. Okay, we're going to go through it here. How are we going to do that? Is drones have it's what do you call this? Because it's in the air. You fly a drone in the air. So basically, drone can actually move in 360 degrees. Yeah, if you watch the movie Maverick by but it's I forgot the actor. I forgot his name. Tom Cruise, yeah, Tom Cruise, Maverick, yeah. So he was flying a jet in the air, and he was flipping here and there and everything. Just imagine that kind of 360 movement, right? So that's the capability of drone. Anything that flying is in the air, you can actually do that. Okay, so we will want to recognize some of the what we call this, the movement. So I would like to do a short activity with you all, guys. Okay, right in front of your screen, in front of the camera. Now put your hands up, your right hand on your left hand, right? Imagine that this hand, your palm, is actually the drone. I'll move it like this, macam ular, right? Hope you are watching the webcam. I'm showing it right now, demo, using your hand. So this is your drone. This is your drone. Okay. Now the first movement of the drone, try to make it like this. Oh, yow, 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 yow. Okay. But actually we pronounce as yaw. Okay. So this movement to the left and right. So drone can actually move like this, spin to the left, spin to the right. And this is what we call as yaw, Y-A-W, right? Now, the second movement is that, now, let's do roti canai sikit. You just turn like this. Okay? So spinning like this is what we call is the movement of roll. Roll to the left, roll to the right, roll to the left, roll to the right. Yaw to the left, yaw to the right, yaw to the left, yaw to the right. All right? Now we're going to add in another movement, pitch. Let's learn a little bit Mandarin. Lai, 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 lai. I'm sure all of you know, right? So this movement is actually what we call as pitching. Pitch down, pitch up. Pitch down, pitch up. So the drone can actually pitch down in order for it to go forward. Pitch up for it to go backward. Okay? Okay, and the last one, of course, is throttle going up, just like that. Now, imagine if you add your, now I want you guys to do this. This is a challenge. I want you to add up all the movements and show it right in front of the webcam. Maybe our technician can record this down. This is going to be interesting. Okay, everyone in front of your webcam, take up your drone, I mean your hand. Okay, now let's do this together. We're going to yaw. Everyone yaw, and we're going to roll. And we're going to pitch, lie, pitch. Okay, one more time, exercise. Yaw, roll, pitch, lie. Okay, and let's mix all of it. Yaw, roll, macam ni lah jadi. Okay, don't do that because you're going to crash the drone. Okay, you don't do that. Okay. Anyway, congratulations. I believe you have understood the basic movement of a drone. All right. Now, moving on from here. Let's go to its application. Okay, I need to speed up because I've been told I have to finish my session before 12 o'clock midnight. That's the truth. Okay, don't worry, I will keep my promise. Okay, let's continue. Application, as you all know, we can do mapping or topography, right? So we can do all kinds of mapping. Remember this, drone is a kind of vehicle. It is meant to do a job. And what is the job? That depends on this. So for this case, the job is to do mapping. So in order for it to do the mapping, you need to have the proper equipment, such as the camera. And in order for us to get the huge map, like what you see over here, you can't take a single picture to represent the whole thing over here. That's not going to be accurate. So that's why what people do is that they actually take the map. I mean, they snap pictures, a portion by portion by portion and portion. Then they take out back the micro SD card, put it back into the PC, and then they do post-processing, or what we call as image processing. You stitch back all those images. You stick back all those multiple images to make it as one single huge image represents a map. Okay, so mapping. Agriculture, we call this, what do you call this, agriculture, farmer, right? Farmer, right? Okay. This farmer pun kena pandai main drone dah sekarang. So farmer must know how to operate a drone. And if you see one thing that over here, as I said, drone is a kind of vehicle. It depends on your job. So for this case, it wants to spray this pesticide maybe, yeah, or even baja, kan, yeah, for the plants. So this is one purpose of drone. Another purpose of drone is you can actually see the health condition of the plant. Yeah, the health condition. We want to know that this plant has grown to what stage? Maybe first quarter or maybe 50 cm tall and so on. And that's where they use what we call as the NDVI, yeah, normalized difference vegetation index, to see the growth of the plant. And from the camera view, this is the view from the camera. It's a little bit, it's actually very reddish compared to green, right? So our eyes can only see the RGB pictures, but from the drone camera, we can actually know the index to know how healthy is the plant, or is it dead? Yeah, kalau dah mati, if the plant is already died or what, right? So we can actually detect it. The next thing is search and rescue. Yeah, those days I remember when I went for camping. Yeah, when I went for camping in the forest, then my friend was lost. Everyone already exit the forest. And then the teacher will do the head count. 1, 2, 3. Where is Ali? Oh, we left him in the forest. How are we going to find him? There's no other way. We have to go back into the forest and find him. But these days, I will tell the teacher, you don't have to go back to the forest. Just send a drone. Okay, so send a drone and get the correct camera. We're going to use the thermal camera. So look at this picture over here, the black and white camera. I mean the black and white image. So immediately you can see, oh, Ali is somewhere around here and he has some few friends together with him. This is just an example, okay? So we can immediately know and locate the person. Yeah. Next, inspection work, engineering and so on, to find out any leakage. Just imagine this picture on the top left. Yeah, by the way, all these images, you can get it from the internet, okay? Yeah, these are all from the internet. I do not hold any credits to those images, yeah? Okay, so this pipeline, if you see on your naked eyes, you don't see anything wrong with this pipe. But under the camera, you look at this, there's lots of leakage actually happening over here. Yeah. So this one is, we are using this thermal camera. Yeah. And even in mangrove. Yeah. So this is picture over here. This is just on the roadside. And there's some muddy land over here with some trees, and there's sea over here, sea water, right? So this is the naked eye view. But looking under the camera, we can actually know, oh, there are actually some water spot at this area down here. So maybe this will be useful for your mangrove research and so on. All right. Continue from here. Natural disaster, sending disinfection work, firefighting, right? And so on, right? Domino pizza, we can send delivery. Okay. Okay, so later on, for your information, Post Laju Malaysia is actually doing a research and going towards this direction as well. Yeah. So in future, you're going to see drones are flying, sending parcels to your house, to your doorstep. But please, I would like to warn you one thing. When the parcel arrives at your doorstep, take the parcel, don't take the drone. Okay, that's another joke. Okay, sorry. Yeah, take the parcel, don't take the drone. Let the drone fly back and do its work. Okay, continue from here, guys. Now, this one, I believe everyone's hobby. You would like to see something from the air. And this is actually the aerial view of UTM I took from my drone. Yeah, aerial photography. And let's have a look. Oh, suddenly I can't hear my voice. Can you hear my voice? Sound check, test, 2, 3.
Yes, Doctor.
Sound check. Can you hear my voice?
Yes.
Oh, you can hear my voice. Okay. Okay. Nice.
Yes.
So
sorry,
cinematic
Doctor, you
movies.
have. Sorry, Doctor, you have
right?
another
Imagine
5
you are
minutes.
shooting the mangrove island and so on, right? You capture some beautiful footage for your research or for your homework. And this is one of my work I did. I mean, my students are doing it in the lab, like Professor Atif mentioned just now, artificial intelligence, object detections, facial recognition, right? So these are all the 9 critical 4th industrial revolution technology integrating into drones. Right, moving on from here. Okay, this is one of my extreme hobby, racing. Yeah, so you can even have some new age, new style of racing in the air. Yeah, I believe many of you will be interested in this, especially those who are involved in first-person shooting games. Any one of you know what is first-person shooting game? Are you a gamer? Please type in the chat box. Yes, I am a gamer. Anyone? Let's see. Anyone gamers? We can't see ours. Okay. Okay, guys. I need to move on from here.
Doctor.
This
Doctor.
is another video, you know. So these are some of the footage from my drones. Okay, this is the last slide. Last but not least, like I mentioned just now, guys, I need to double check with you if you can hear my voice. Sound check.
Hello. Yeah, Doctor. Yeah, we can hear you.
Thank you very much. Okay, this is my last slide. This is, I would say, the most important of all, because people tend to think that drones are easily accessible today. You can just order from online, it will deliver to your house, and then you can fly a drone. But please always take note on the safety precautions, the rules and regulations that we have, because you may accidentally violated some of these rules, and worst case, you can go to jail. Yeah, worst case, you can go to jail. So whenever you fly a drone, okay, remember, you have to fly at least 50 meters away from any individual. Okay? And the drone should not be heavier than 20 kg. But my advice, most of the drone, if you are flying for hobby, not more than 250 grams. So if you're going to fly any drone, don't fly anything above on 250 grams for hobby purpose. Okay. And you do not fly on the housing area. Or let's go and see what Adi, my neighbor, is doing. Okay, don't do that. Okay, that's actually violating people's privacy. Okay, and you don't fly close to airports, pasar malam, people playing football in the field, you fly over the heads, right? These are all violations of rules. Although many people are doing it, I would say some people are doing it because they want to record events and so on. You can do that, but with proper permission. Okay, seek permission and permits from the authority. Okay, so how would you get into this field of drone? First of all, don't start by immediately flying a drone like I have it over here. You can start by flying all these simple drones. These are all not dangerous. It's not harmful. It's a hobby grade, right? And if you don't know how to fly a drone, you can always use a simulator. Just type online, Google search, drone simulator, free drone simulator. You will get some of the software, download, and try to fly a drone just like you are playing a video game. So once you are familiar with the movement, like all those roll, yaw, remember we did just now, if you are familiar with those movements already, then you can start to go into some hobby grade drones. And I would recommend some of the drones, such as in the pictures over here, starting from the very left. That's a very good start. On the very right, that is a little bit extreme. When you go a little bit advanced, then you can join the team, join the community to learn on how to fly that kind of drone. So with that, that's my session for today. And yeah, if you go forward, you can actually watch many of the videos about drones on Drone Edu Challenge IR 4.0 in the YouTube channel. So with that, I have come to the end of my session. And please don't go anywhere because we have our next speaker. I would like to invite Dr. Nurliza. Over to you, Dr. Nurliza. I'm going to stop sharing this. Okay.
Thank you, Dr. J, for your interesting presentation on drone. So I believe you have more than 5 drone, right, on yourself? So maybe I can borrow your drone for the monitoring work in the forestry.
You are most welcome, Doctor. Yeah.
Okay, so now we continue our webinar in Mangrove Education. So I would like to focus more on the application, okay, the application of drone. But before that, I would like to introduce what is the terms or the fundamental of drone before we go for the application. Okay, so let me share my slide. I hope all of our students or participants still with us. Okay. Okay, so this is the slide. Okay, so Mrs. Zalika, what time I have? How many times I have? Complete my presentation.
Yes, sorry, Doctor, you have less than, currently it's 3:39. So yes, we may stop at 4:10. So I guess that you may have another around 25 minutes.
Okay, I will try. Okay, so I think Mrs. Alika already introduced myself. Okay, is my slide okay? You can view my slide.
Yes, Doctor.
Okay, so I'm Nuriza Kamaludin from the Faculty of Forestry and Environment, UPM. So when we talk about mangrove, so mangrove, we have forest in the mangrove, okay, ataupun in Malay we call it as hutan paya laut. Okay, so in the previous 3 webinars, we also learn about the hutan paya laut. Okay, so I continue what is the main points of the discussion today. So I would like to introduce or talk the fundamental about geospatial technology, which is the drone is inside this geospatial technology that can help us in mangrove conservation. And next I will talk about what drone can do for mangrove. And the last one, I will make a tour, free tour, virtual tour for you, okay? Because in this pandemic era, most of virtual tour are now popular. For example, a zoo Tour, okay, Malacca Zoo Tour, National Zoo Tour. So now I would like to bring you to Mangrove Tour. Okay, so what is geospatial technology? So in these pictures, this is not my pictures. Okay, in these pictures we can see here. Okay, there is some of instrument or tools that we call it as satellite. Okay, the satellite is far from our Earth, located at space. Okay, so that is the first insight of what we call it as remote sensing. Okay, so remote sensing, that is from sensor. Okay, sensor. Okay, and what else in the geospatial technology is geographic information system, or in short GIS. And the last one is global positioning system, GPS. Okay, you can before this, Dr. J show you the GPS embedded in the drone. So we also that kind of technology, or that kind of system is interpreted or is known as the geospatial technology. So that's why we can use drone in conservation management for mangrove. Okay. So what these three can do is provide ability to integrate and visualize data. Okay, so what kind of data that these three system or these three tools can provide us? Okay, most of data has a spatial component. Okay, so participants or students, can you maybe type in chat, what do you know about spatial? Okay, I think most of you in the Form 1, Form 2, Form 3, okay, and you already took geography subject. Okay, what is the main or fundamental in geography subject? Fundamental keyword that you need to know in geography. I think in the chat, space, land, topography. Yes, we geography is also about topography. Yeah, other than that, so no, you cannot suggest what is spatial. Okay, spatial is about location. Okay, it's about location, and also location. That is the geospatial technology. Okay, that all these three systems can accommodate to visualize the data in location. Okay, actually we have been applying or using this geospatial technology in our daily life, especially during this pandemic, where we are trapped in our house. Okay, we are not going for shopping, we're not going for dine-in. Okay, so there is many apps that we have now have this kind of spatial component or location. Okay, so anyone can guess what it is? You can type in the chat what it is, a kind of apps that offer location for you. The map. Okay. My slide's not moving. Okay, so we have a Google Map, okay, location, and another example is Waze. There's lots of application nowadays that have location that help us in our daily life. Okay, so now I proceed to the fundamental of remote sensing. So I will go one by one. Remote sensing, geography information system, GIS, and the last one is global positioning system, okay, GPS. So when we talk about remote sensing, so remote sensing is satellite that installed out of our Earth space. Okay, is so from that remote from the sensor we get to know what is on the Earth. So it captures all the object on the Earth. Okay, before this, OTJ show that the camera attached to the drone can capture the view or the sceneries. So it's also same with the remote sensing or sensor at the outer space. Okay, so nowadays, parallel with the advancement of the technology, okay, towards IR 4.0. So we have a drone, we have aircraft that help in capturing object on the earth. Okay, nowadays. So this one, the sensor that is installed out of the space, our space that is managed by NASA. Okay, NASA is National Aeronautics and Space Administration, US. So this is from this mapping or this image capture was in large scale. Okay, but with this drone or aircraft, aeroplane, so this one is in the small scale. Okay, depends on the capability of the drone or aeroplane aircraft that we use. Okay, so this one is example that the sensor that we install at the drone or at the aircraft capture the image, so they detect object on the earth. Okay, so how it detect or the image captured, okay, object on the earth. Okay, so to detect object on the earth, the sensor need to have a source of energy. Okay, so for remote sensing, a sensor that is installed outside of our space, the source of energy is sunlight. Okay, so cahaya matahari. Okay, the source of energy will be transmitted to the object on the earth. So the earth on the object on the earth, so they have electromagnetic radiation from the energy. Okay, after that, the object on the earth here, okay, we reflect this energy. Okay, we reflect this energy to the sensor that we have. Okay, so the sensor will be a satellite sensor. Okay, and if we use drone or we use aeroplane, the sensor will be the camera that attached to the drone. Okay, so all the object captured from the earth here is detected by the electromagnetic radiation produced by the energy that we have. Okay, source of energy of the sunlight. Okay, so now, so this is the most popular now, I think. Okay, this is a basic principle, a basic fundamental how the sensor capture the image. Okay, so the common camera that we use is our phone. Okay, so we have, for example, here we have the object here. Okay, the phone. Okay, so we have usually when we took pictures during the day, the light. So we already have the sunlight or maybe the natural light. Okay, but when we took the pictures during the night, we might have the what we call it as the light here, okay, in the camera. So that is the source of energy that we have in our camera. So this is example of RGB, red, green, and blue. Okay, like Dr. J said, she installed the RGB camera in the drone. Okay, for RGB. So this is how the image capture and also the concept of our remote sensing. Okay, the source of energy. So we have electromagnetic radiation transmitted to the object that we want to capture. Okay, and then the electromagnetic radiation makes the interaction with the object. Okay, they can read the EMR or electromagnetic radiation can read what is on the object here on the earth. Okay, and then the energy will make the reflection towards the sensor. Okay, so the sensor, of course, our cameras, because I'm going I show you the basic principle of our camera, how the camera, our RGB camera capture the image. Okay, and then we have the image. Okay, recording the image by the detector. So they have a detector in the camera. And then we can do the analysis, okay, of the imagery by analyzing or differentiating the different tone of color here. Okay, that is how the sensor can detect any different object on the Earth. Okay, on the Earth we have building, we have vegetation, we have water, we have land, different types of vegetation, okay, different types of building with different types of roof system. So when we have the electromagnetic radiation and the source of energy, so we can detect all of it one by one. Okay, so here we have the building and also the trees. So the trees is vegetation, the source of energy transmit the electromagnetic radiation to the object on the Earth. Okay, and then sensor we capture all the image. Okay, and the image, the reflection here, there is interaction and reflected to the sensor, and then sensor will give the information. Okay, they record it into the ground system. Okay, in Malaysia we have one ground system for satellite sensor. Yes, the satellite sensor is managed by NASA, okay, in US, but we have the rights because we our country subscribe several types of image, okay, but it's managed by Malaysian Space Agency located in Kuala Lumpur. Okay, but the ground station for MEITA, Malaysian Special Agency, is in Mentakap, Temerloh. Okay, ada orang Mentakap Temerloh sini. We are flying to Mentakap now. I hope my screen working, because I'm showing you the ground station Mentakap. Mrs. Zalika, my screen working?
Yes, Doctor.
Okay,
It's working.
So we are. This is the ground station for Malaysian Space Agency. Okay, for our country to capture the image using the sensor. Okay, so this ground station, they have facilities, okay, to analyze the data, and then the data that analyzed that is still in raw product. Okay, the raw product and they transfer to the headquarters in Kuala Lumpur. Okay, so I'm showing you. Okay, so we are moving from Temerloh to the headquarters in Kuala Lumpur here. So siapa yang ada dekat Kuala Lumpur ni, mungkin siapa tahulah yang ada dekat Sunway Mall. Okay, that is near to Sunway Mall. Okay, so this is the gate, the main gate for MEITA, Malaysian Space Agency. Okay, before this, they call known as Agency Remote Sensing Malaysia, or ARSM. So that is the how the image from the satellite, okay, out of the space, okay, controlled by NASA, managed by NASA, captured for our government. Okay, so Malaysia actually have our own satellite. Okay, before this, if you heard about Razak-Sat, but it's not working anymore. I'm not sure it's still on the space or in the orbit, or is missing now. Okay, so how does the image look like after we capture using the sensor? Okay, so this one is from our bare eyes. Okay, this one is from the reflectance from the electromagnetic radiation. So this one from human eyes, we can see the green if we detect a vegetation. We can see like soil, earth color if we detect soil. Okay, and also we can see kind of blue or black color if we detect water. Okay, but if we interpret the data or analyze the image that we captures in the reflectors, in the electromagnetic radiations, okay, so we can have different colors. So these different colors, how we want to identify different colors is for different is for which object is by looking at its reflectors. Okay, the unit is percentage and this wavelength, and the unit is wavelength or lambda. Okay, this is how we need to identify, okay, the reflectance or the radiation that the object have from the source of energy or the sunlight, then transferred to the sensor. Okay, mentioned we remove the chip from the drone and then we put it in the computer and then we analyze the image. So we analyze the electromagnetic radiation based on this reflected wavelength. So usually vegetation is detected within this 400 to 800 wavelength. Okay, so for water it detects less than 400. Okay, so there is several objects that can be detected by within this 800 to 2400. So that is the fundamental of remote sensing. So geographic information system, which I can interpret it myself, I can interpret it as easier than remote sensing because we don't deal with the different color because of loss of, as we see here, we have more than 2,000 colors to differentiate. But in GIS, it's very simple. Okay, it's based on topology. Okay, but the data entry, so we have 5 elements in geographic information that is capture, store, query, analyze, and finally display our final map or final location. We can identify our location, or we want to display what is our objective that we want to achieve. Okay, so capture, data entry, data editing, geometric transformation, projection, and reprojection. So usually this is coming from the remote sensing. So that is the first initial data. So after we capture the data, so here I show you the image that already processed. So after we make the analysis on the reflectance, on the wavelength of the objects, so we identify, for example, here we identify 5 objects on the earth. That is the village. Okay, we can identify the boundary of the village. Okay, the access road. Okay, the river, bridge, and school. Okay, so we have 5 objects detected from our first image capture. Okay, and then we store all this image that we captured in layer. We call it as layer. Macam kuih lapis tu. Okay, we need to install it. We need to store it in a layer. So each layer has different object. Okay, and to identify which object in the layer, so we have attribute table. We call it as attribute table. Okay, for example, here this one is village, polygon for village, a layer for village. We have polygon ID 1. Okay, so the description is a village A. Okay, for polygon ID 2, description is village B. Okay, and village C for polygon ID number 3, 4 village D. Okay, polygon ID number 5, village E, and polygon ID number 6 is village F. Okay, this is the example. Okay, so we also can input all another information that can describe our village. Okay, for example, for village A, we have 50 population with total area of that village is 120 hectares. Okay, so you may add up any other information that you want to. Okay, if you work with GIS. Okay, and also here I have example of road. Okay, road name. Okay, road name 1, ID 1, ID 2, and ID 3. We have the street name. We have the length in meter, and we have the year constructed. Maybe you can add up more information. For example, types of road. Maybe it's gravel, or premix, or tar road. Okay, so this is the information that we call it as attribute table. Okay, from this store we have the data. We have stored the information of our data. So then we can make a query. Okay, query from these layers. For example, these 2 layers. So I live in village F, which is in ID polygon ID number 6, and I want to travel to village A. Okay, which is in ID 1A here. So how I want to get to village A? from village F. Okay, that is the query that we can do. Okay, so the query here. Okay, so we overlay these two layers and identify which road that I can take to reach village A. Okay, so here you may give the description for me. Okay, you might give the description for me. You take the you can suggest me take the Anggrek Street. Okay, this is the polygon number 3. Okay, if you remember, because of we have the ID. Okay, this is the road line number 2, and this one is line number 1. Okay, take the Anggrek Street. Okay, from this village F, polygon ID number 6, and then turn left to Rimba Street. Okay, the second road or the second street, and then we turn right to Gentayu Street and cross the river by bridge. We have the bridge because when we overlay all the information or overlay all the layer, we can know what is the barrier, what is the any object that exists in our area. Okay, so after that we can reach the village A. This is the verbal direction that we can give. Okay, if someone asks you to from village A to reach the village, from village F to reach the village A. Okay, but if we use a Waze or Google Map, you can have the time also to reach that village, and also how far road Anggrek or how far road Rimba and how far road Gentayu that you can that you need to take. Okay, so this is kind of a verbal direction. Okay, so this is what JS can do.
Doctor, sorry, you have another 5 more minutes.
Okay, I will try to make it faster. Thank you, Mrs. Alika. Okay, last another thing that we can do is from this layer that we layered overlay all the 5 layers that we have, 5 objects that we have. Okay, for example, distance from village to nearest school, okay, nearest education place for villages when there is a disaster such as floods, because nowadays most of school have been used by the NATMA agency for shelter during the flood event. Okay, and also the river boundary, at what level the river water will be or river water will raise when there is heavy rain, and length of road access for each villages, road access for evacuation and rescue. This is the most important that can help the fire and rescue department to help you during the flood event. Okay. And last one is display. We display our map, or we display our final layer. Okay, with the title of the map. Okay, and also we have the legend. Okay, so the legend is, make sure the legend is tally with what we showed in our map. Okay, and also we need to have a scale bar in show the unit, and also we need to have the north arrow. Okay, that is the example of geographic information system. Okay, in this one is from geographic book, geography subject book, form 2. So you can interpret this map by its symbol. Okay, the petunjuk, and you also have the skala. The skala is shown by ratio. Okay, and you have the title here. So kat sini, here you can answer the question that that shown here. Okay, senaraikan 3 kegiatan ekonomi jangka penduduk dalam peta di atas based on the land use maybe. Okay, padi sawah, kelapa sawit, getah, and in your opinion, why there is no shelter residential in the northeast of the map. Okay, Timur Laut. Okay, because of there is kelapa sawit here. Okay, so this is, you can query, you can make query, and you can make analyze. So that is same with when we use this kind of remote sensing, and we can use this kind of GIS in mangrove conservation. Okay, the last one of geospatial technology is global positioning system, or GPS. Okay, GPS is it is a satellite-based navigation system. Okay, there are three main parts of the GPS. We need to have satellite. Okay, satellite. If we look at the pictures here, they have 4. So we need to have at least 4 satellites detected by the receivers. Okay, we need at least 4 satellites. So actually, we have 24 satellites placed in our orbit, okay, to help us in navigate our location. Okay. And the last one is receivers. Okay, so nowadays, so there is lots of apps, okay, ready in our phone and also in our tablet, okay, that detect our location. Okay, so as mentioned before, for example, Google Map, Waze, okay, now Grab, Food Panda. There's lots of navigation system that we have, navigation apps, actually navigation apps that we have in our phone. Okay, it's all require a GPS signal that is detected by the satellite. Okay, and then we use them. Okay, we use them in our daily life. Okay, this is the example. And also we can detect the movement of flight. Okay, because during this pandemic, we cannot travel, we cannot go travel with aeroplane. Maybe we can look at the movement of the flight. I think is okay. So for example, for students or participants who usually travel with your parents, okay, with flight, or maybe the secretariat travel with flight, so you can see, okay, how the flight is moving. Okay, kalau you all lupa, okay, so this is the example of application or software that we have. Okay, live flight aware. Okay, so we have the flight number and also the estimated time of arrival here. That is the example that they use a location, okay, GPS, global positioning system. So we use this global position without our realize, okay, without our known that we use this kind of global positioning system in our life. Okay, so what drone can do for mangrove? Okay, so this is the example. Okay, they use this drone. So I'm not sure the name of this drone. Maybe Dr. J get annoyed. So how heavy it is. Okay, and also there is maybe there is I think there is for seeding, okay, drone seeding to plant mangrove seed, okay, in mangrove area or muddy area. As we know before in the previous webinar, you understand that mangrove is quite difficult to access and also muddy because of tidal event and also because of the root system. So it's difficult for us to get into the mangrove. Okay, so this is the example. They do the mangrove seeding. Okay, that is like a bow. Okay, of course, this what we call it as capsule. The capsule is maybe they construct the capsule. They make the capsule from the material that can decompose by itself, okay, and have material to help the seed grows by itself. Okay, and also drone can do for tree height measurement, okay, carbon measurement, landslide. Okay, here we have trees. We can detect the height of the trees if we use the right sensor or the right camera, and we identify it correctly from the different color reflectors. Okay, you remember that I showed you before that from the electromagnetic radiation, we have more than 2,000 wavelength. So different wavelength will detect different objects. So we can detect this kind of tree height, carbon content, and also landslide. Okay, for landslide, maybe we need to use more than one image. Okay, because of landslides occur temporarily. Okay, we need to have 2 temporal image. For example, we took the image from January to 2021, and then we need to observe that area. So we capture the image again in the next 3 months or in the next 6 months. So we monitor the changes if there is changes of landslide, or maybe there is tree that fall, or maybe your seed that does not germinate, and then you need to replant or send back your drone to make the seeding process. Okay, drone seeding, for example. Okay. And also tree disease. Okay, different disease can be detected by electromagnetic radiation. Okay, so different tree species also can be detected. Okay, for example, here we have reflectance and wavelength in micrometer or lambda in more than 2,000 wavelength. So there are 19 species that this is from my project. This is the 19 species of mangrove detected by our sensor. This is from hyperspectral. Okay, and then from this 19 species, we sample at several regions. Okay, this one is in Perak. Okay, siapa yang daripada Perak? This one is in Taiping. Okay, Matang Mangrove Forest. Okay, Taiping, Selangor, Perak. Okay, this one after we detect this kind of reflectors from different radiation or different wavelength, and then we can map or make the automation in mapping for the overall area, for the whole area of this forest. Okay, this one is Batam Mangrove Forest Reserve. But before that, we need to have the boundary of this area. Okay, to make it that our mapping, what is the border or boundary of our mapping. Okay, so this is the legend. Okay, so different color shows different species of mangrove tree. Okay, and also drone can help in water quality. Okay, mangrove because of mangroves always related with sea. Okay, so we need to measure the water quality. Okay, the water quality is because of sometimes there is garbage thrown to the coastal area, and the waste of garbage floating in the sea, okay, or the coastal area, so it might pollute the water. So the quality of the water might be reduced or might be good. Okay, and also there is some of aquaculture activities that might change the quality of the water. Okay, so this is the example of drone that have the water dipper ataupun dia ada bottle sampler that can carry the water, okay, to the land, and then we take the water and we do the sampling. Okay, and this one is a drone with camera. We do the image. Okay, and also any detectors of degradation, for example, when there is oil spill, so we can differentiate it by the reflectance or wavelength. Okay. So now, Mrs. Narika, I hope, can you give me a 5 minutes emergency time? So this is the mangrove tour that I promised. Okay, so I hope this is working. It's not working here. I need to. Okay. So this one is from Taiping, Perak. Okay. Okay. Let's we see here what we have here. Okay. This is the mangrove in the Taiping, Perak. Okay. We have the trees and we have the clear water here. Okay. This is the beauty of mangrove tree fruiting season. Okay, as you know that mangrove trees have this kind of seed. Okay, when they drop in the water, so they can survive. Okay, and also they have buoyancy. Okay, to remain at its place. Okay, kalau kita tengok macam ni, macam kacang panjang. Is another example. This is from real pictures. Okay, this one is harvesting operation in mangrove. So in Taiping, most of the trees, the end product is charcoal. Okay, so they use this mangrove tree, bakau minyak and bakau kerap as charcoal. Okay, this one is a water sampling. So this is manual water sampling. So my team don't have a drone equipped with water dipper to collect the sample. So we use the manual water sampling, okay, by boat. Okay, I have several pictures here to show you. Okay, and this one is laborious work, okay, to do the tree height measurement. Okay, so we need to step up into the mangrove roots to measure the diameter of the trees, and also as you can see here, there is loss of root system that might be dangerous for us to walk in this mangrove area. Okay, so it has several pictures. So now, okay, so this is the beauty of mangrove. Okay, and also we do fishing in mangrove. Okay, this is the situation during the late afternoon. Okay, and also this is during the tidal event, high tide. So it's very difficult to move during this situation, this tidal event. So we cannot see which ground we need to step our foot. Okay, so if we miss the route or we miss the ground, we might be slip or we might be fall. Okay, so look here, and okay, as you see here, there is because of the mud. Sometimes when I go to the mangrove, so I always going down into the mud because of the heavy that we have, okay, weight I have. Okay, so this is the situation. It is the manual mangrove conservation. So might be the robot maybe help in fastening or maybe advancing the monitoring of conservation in the mangrove. Okay, so you can see here it's almost the knee. So this is the mud in the mangrove. Okay, so now I would like to take you to the Sijangkang mangrove. Okay, from the Taiping Perak, we move to Sijangkang. So Sijangkang is the main study area for this project, MEITA, as I understand. Okay, so I don't have the pictures for Sijangkang, but there is somebody that upload the pictures in the Google Earth that you can see. So this is the pictures of view in the Sijangkang, and then we move to Kemaman. So all of our course in Peninsular Malaysia, we have mangrove, but not in large area as in Matang, Perak. Okay, this is in Kemaman. Okay, in Kemaman, we move to southern region of Peninsular Malaysia, Lingi. Okay, Lingi is the border between Negeri Sembilan and Melaka. So this is the mangrove situation. So we can see here several one mangrove tree. Okay, and now we move to Cook in the southern region. Okay, this is Cook mangrove. Okay, maybe you can travel by yourself, okay, using the Google Earth. So how the Google Earth work is also same with drone that we might use in mangrove conservation. Yeah, unless the difference is we use the different camera, because we use electromagnetic radiation camera to detect any objects on the Earth. Okay, so Google Earth is just RGB image to show you the RGB image. Now we move, we fly to Langkawi. So now is bubble Langkawi. Okay, pelancongan Gelembung Langkawi. So siapa yang tak dapat pergi lagi Langkawi, so I took you all here in Langkawi. Okay, so this is the pictures. Okay, so there is lots of mangrove. Okay, I saw some of you from Sabah, Lahad Datu. So maybe can go to mangrove in Lahad Datu. Otomaru. Reply. So there is a lot of pictures that you can see from the Google Earth. Okay, so I think that's all from me, Mrs. Zalika. So I hope you enjoy, and also you can make your own tour using Google Earth, because we are restricted to go for a holiday right now, and there is a state border restriction. We're still in the state border restriction movement. So maybe you can go your own travel by using this Google Earth. Okay, because of this Google Earth, all image this Google Earth is captured by the sensor that is installed in our outer space. Okay, thank you. Back to you, Mrs. Zalika.
Thank you, Dr. Narisa, for sharing about this topic. And now we are going to open for the Q&A session. I'm very sorry because we are going to end the session at 4:30. So we might have might be some of the questions that cannot be answered today. I will email to all the speakers, and we will send this answered Q&As answered in our Facebook page. So maybe we have like a few more times. So maybe I will have a look on the questions, and we will answer some of them. I think some of them Prof. Atif already answered in the chat box. So let me add the spotlight first. Okay, so now I will read one of the questions. This is from Isaac. He asked which type and what average the price of the drone. I think this is related to Dr. J. Suman. Which type and what average the price of the drone suitable to do the conservation? Where to buy cheapest drone? Heat camera, RGB camera, multi-spectral camera. This one is by Omar Faruqi.
Okay, thank you for the question about pricing, right? About pricing. Well,
Yes.
Just to double check, my voice sound check test. Can you hear?
Okay.
Right, okay. The cheapest drone for, like I recommend, if you're a first timer, never fly a drone before, yeah, go for second hand. Go for second hand. You can get just few $100, and the best is I would recommend you to buy this one I'm having here. This is an educational drone. It's very stable. It has an ultrasound sensor. It's easy to fly. You can even do programming with it. So this is a good start. You can get cheaper drone than this, but I would not recommend, because the flying experience would be best to start from this. And when you talk about cameras, other than RGB cameras, it's going to cost you a lot. It can easily cost thousands to hundreds of thousands of ringgits on a multi-spectral camera, hyper spectral camera. Even LiDAR is very expensive. So that's why many people, when they buy LiDAR camera and sensor and so on, we dare not attach those camera on the drone, because we're afraid if the drone fly away, then the money fly away together. Yeah. So for just a normal use, I would say just use a simple RGB camera should be fine. Yeah, and then you can do some image processing to actually assist, unless you really have the investment for that. Hopefully, I give you a brief answer on that.
Okay, thank you, Doctor. I think mostly the questions is about drones, because the next one is by Ahmad Daniel from SMK Agasih Lahad Datu. Adakah hanya drone dan robot yang spesifikasi yang digunakan? I think this is in regards to the conservation of mangrove. So this is his questions.
Prof. Atif, you want to share something? There's a word robot over there as well.
I think at the moment, mainly robotics are still new in conservation activity. Even in MEITA community, we are still discussing on how we can utilize robotic at the best. At the moment, the work that was being done by Dr. Narisa is the most applicable, I can say, on how to do detection on different kind of mangroves, the topology and so on. The mobile base is quite challenging because of the structure of the roots and the condition of wet and dry area. I believe for underwater, the main challenges for underwater robot is the feedback camera, because when we cannot see underwater, so the robot will not also see. So that is the same problem. So we have to replace this with other kind of sensors. But the objective is the problem statement and how we want to derive based on the objective is very important. So that is something that we have to talk with the experts in mangrove area. So from the robotics side, we can provide some of the solution, but whether the solution is in line with the demand from the expert. So that is some of the negotiation and discussion that we are still doing. So I believe at the moment, drone is the best technology for conservation, but underwater and ground robots are also having potentials.
Okay. Thank you, Doctor. And another question is from Anis Shafika. What is the benefits of using helicopter drone types?
Yeah, I guess that's to me, right?
Yes,
Okay.
sorry.
Okay, helicopter, like I mentioned in the slide, that's a single rotor type of drone, right? The advantage is that it can carry heavy payload, yeah? It can fly slightly longer than multi-rotor, right? But then the maintenance and the build and the complexity is much more tedious than multi-rotor. Yeah, so that's why these days people don't really use that unless it's really necessary. People really go more on the multi-rotor such as quadcopter.
Thank you. Another question: Are drone used to do the conservation under the water? I think that this one mentioned by Prof. Active, yeah? It can be used underwater.
It can be used because we have underwater drone as well. If you remember the slide that I show on the underwater robot in green color that we use for turtles, that is also considered as underwater drone. But it is meant for high visibility area lah. So contohnya macam dekat Sabah ke, tengok apa tu dekat Sabah Penyu dan sebagainya, that will be the best. But in murky water, so it's quite challenging because kita tak boleh nampak apa benda yang ada dekat bawah tanah. So we have to replace the camera with other kind of sensors. Maybe Dr. Noriza have experience with crab. I believe Dr. Noriza can also explain what are the methods that currently being used, and we can try to see how it can be assisted by robots later.
I think Dr. Noriza connection is disconnected. I think Dr. Noriza disconnected, but maybe I can go through another questions by Nur Iman. I think this would be the last questions. How far and how long can drone fly?
Okay, how far and how long can drone fly? That depends on how far do you want, how long do you want, then we decide. Okay, for example, you cannot have, it depends on the weight, okay? It depends on the weight. So if you want to fly far, like I mentioned just now, if you want to fly far, the drone has to be as light as possible, yeah? If you want to carry heavy weights, payloads, then the drone has to be as powerful as possible. So there's always a drawback, yeah? So like I mentioned, some of the example, if you're going to fly for the purpose of mapping mangrove, in a very big scale, for example, 100 acres. Yeah, 100 acres, that's very big. So multi-rotor may not be suitable. May not be suitable. The better choice to do that is to use fixed wing. Yeah, fixed wing with some advanced camera under it. Then you can fly long, you can capture many images. Once it lands, then only we can do the post-processing. Or another method is that you can use multi-rotor if you don't have fixed wing. Multi-rotor, fly several times, landing, charge balik battery, fly lagi, landing, charge balik battery, fly lagi, and collect data. So there are two methods. Depends, like I said, how far do you want to fly, how long do you want to fly, then you customize the drone.
Thank you, Doctor. Oh yes, Dr. Noriza is here now.
I may add something. Dr. J, there is mighty practice.
Sorry, Dr. Noriza, your sound is cutting off.
And come back.
Sorry,
Oh,
Dr.
yes.
Noriza. Yeah, your voice is cutting off. Actually, it's breaking up.
Okay, so my internet is lagging because of 4:30, I think. It's already 4:30. Okay, Dr. J, that is my team practice. We use a quadcopter to capture the image in mangrove and also in the inland forest. So we need to ask our drone come back after 20 minutes. We change the battery and then we fly it back into the flight path, go back to the flight path. And then after 30 minutes, it come back to us. We change the battery and then until we finish the mapping.
Okay, thank you, Doctor. I think we are already end of our session, Q&A session. So if students, if you have any more questions, please drop your questions down in the chat box, and maybe later I will email all the questions to all the speakers to answer and put it in our Facebook page, Kelab Pencinta Alam. And to Dr. Noriza, Dr. J. Suman, and also Prof. Prof. Atif from MNS and UPM side, we would like to say thank you again for joining us today for this. Now it's already raining. I think everyone is having an issue with the Wi-Fi and connections. So I guess that before we go any further, I have an announcement by Dr. Evelyn. Yes, Doctor, are you here? So we are going to have a quiz contest. So if you all must know, we are launching it today, and it will be until this Sunday. So I'm going to
Yes, yeah. Okay, thank you, Zalika. So in our third webinar on the 22nd of September, we actually announced the Pertandingan Menulis Essay, which is the essay writing competition. So that is one option that you can choose to share with us, on mangroves. Today, I will be sharing with you on the quiz Alam Semula Jadi Bakau, or quiz on mangrove, So this quiz will be open from 6th to 10th of October. So you have about 5 days for you anytime to actually fill in this quiz. There are about 40 questions, which consists of questions from webinar 1, 2, 3, and 4. Okay. So this quiz is actually open to all registered attendees of this webinar, and who are between 13 to 19 years old. So you must be registered for you to be able to answer this quiz. So if you did not attend any of the webinar, but you actually joined the quiz, you will not be able to receive a cert lah. Okay, all right. So and we are also giving out prizes for those who do excellently well in this quiz. So for first prize, you will have merchandise item worth 100, 80, 60, 50, and 40. So we have 5 main prizes that we are offering for those who are participating in this quiz. Okay, so all participants who register and submit your quiz answer, you will receive a certificate. All right. And as Puan Zalika has informed, they will be providing you, we will be able to provide you the results by end of October. Okay, so how do you get these quiz questions? It is through this link, which we will copy paste on the chat box later by Kak Izzati. And this link will also be given to you through the MNS communication networks. Okay, so that's basically it. I do encourage you to join us in this quiz, because this is also one way of you sharing, helping us to reflect on what have you attained or obtained from these webinar sessions, and as well as for you to obtain a certificate which is endorsed by the Ministry of Education. Okay, with that, thank you very much. Over back to you, Puan Zalika.
Thank you, Dr. Evelyn. Now we are at the end of the sessions, but before we go, I need all of you to turn on your video. So we are going to capture the photos for today's session. And again, to all the speakers, Prof and doctors, thank you so much for sharing with us such interesting topics on the robotics and using the robotics in the mangrove, in the conservation of mangroves. Everyone, please turn on your video. Okay, I'm going to capture the first page, the first screen. Vincent, if you are here, you can also help to capture also, because I have some issue on capturing to get the screenshot. So sorry. Wait, hold on.
Okay, no problem.
Yes,
may I ask everyone to turn on their camera? Because I can see a lot of people haven't turned on their camera yet. Please do. Because I think we want to publish this on our Facebook page as well. So please turn on your camera.
Okay. Are you done with page 1, Vincent?
Not yet. Just give me a moment, because I'm waiting for everyone to turn on their camera.
All right.
Okay. Okay. I'll start taking the pictures, right? Okay.
Mm-hmm. Okay. Vincent, are you done?
Not
You're
yet.
so quiet there.
Oh, give me a second. Give me a second. Give me a second. I can't turn on my camera for some reason. Give me a second. Okay, guys. Okay. All right. I'm done.
Okay.
Thank you, everyone, for your
Thank
cooperation.
you, everyone. Thank you, everyone. And hopefully we will have another series of webinars next time. On behalf of MNS, UPM, and our presenter, thank you for joining us today, and have a great rest of your day. And please don't forget to fill in your attendance form for your certificate. We are sorry for the delay of distributing all the certificates. Please expect in 14 days time. Yeah? And if you have any comments, you can also jot it down in the form that we distribute earlier in the attendance form. Thank you.
Thank you, everyone.
Oh, I'm so sorry. I think like I forgot to unmute everyone. No wonder there's no sound.
Okay, thank
Bye,
you.
everyone. Thank you.
Bye-bye.
Okay, all right.
Thank you. Speaker proaktif. Cepatnya proaktif keluar.
Stay on, yeah, for us to just have a brief discussion ke?
Ada lagi ya.
Okay, Doctor.